All right, for this first question, we have a trapezoid and we want to find the area in simplest radical form. Your area of a triangle, 1/2 the height times base 1 plus base 2. We have one of the bases labeled here, and so we're going to need to find the height and the other base. So I need to find the length of this segment. And then what I'm going to do here, I'm going to drop a height right here. That 60-degree angle is supposed to be that corner angle there. And if I'm dropping a height, I'm dropping that at a right angle. And if this is a 60-degree, this is 90. This is a 30, 60, 90. There's your hypotenuse is 8. So the hypotenuse is twice the short leg. The short leg would be this little piece right here. And then the long leg, which would be the height of the triangle and the height of the trapezoid there, is your short leg times the square root of 3. Now, because this is 4, if this entire length is 15, if I subtract off the 4 here, that makes the rest of this segment 11, which would match up with this segment at the top being 11. So what I have here, my height is 4 roots of 3. One of the bases is 11, the other base is 15, and it really doesn't matter which base you label which, but we're going to just go ahead and plug this into the formula. So 1/2 times 4 roots of 3 times 11 plus 15. And here I'm just going to simplify a little bit. Half of 4 is 2. So this would be 2 roots of 3. And if I add 11 and 15, we're going to get 26. And really, if I want to leave it in radical form, what I can do here is multiply 2 by 26. So that would be 52 roots of 3, and we got feet squared for area here. For question number 2, if you're testing to see if a triangle is acute, right, or obtuse, whoops, we're going to do the Pythagorean Theorem, and we're going to do the sum of the squares of the legs, see how it relates to the hypotenuse. The hypotenuse is the longest side. Right here you're going to get 36 and 64, which is 100. That's going to be less than the square of the hypotenuse, which is 121. So this is going to be obtuse. Now, if the hypotenuse was smaller, which it's not here, but if it was, that would be acute. And if these two things were equal, then you'd have a right triangle. Okay, major arc is more than 180, so in this diagram, that major arc is going to go around that way. So I can call that ADB, or I could also call that BDA. If you have a major arc, it should have 3 letters in it to make sure you're going more than halfway around the circle. And then if this angle is 50, then for that arc AB, that would be the measure of the arc. So the rest of this in a circle would add up to 360. So the measure of the arc I've got highlighted in green there is going to be 360 minus 50, which is 310. Now, for number 4, be really careful with this question. You're going to find the length of this arc. Now, the length of the arc is a portion of the circumference. It's different than the measure. Oh, sorry about that. So, the length of the arc here, what you're going to do, your formula, it's the measure of the arc over 360 times the circumference. So if I do the circumference, that would be all the way around the circle. When I multiply it by this fraction, that gives me the percent of the circumference. I don't want the whole circumference, I just want this much of it. Now, they're giving you the 90-degree angle in the diagram here to allow you to see that the measure of the rest of this arc, which is what you're trying to find, is 270. If you do 360 minus 90, that's where you're going to get that. So my measure of my arc, 270 over 360 times 2 pi, and then the radius there in the diagram is 12. Now, if we want to leave this in terms of pi, what I'm going to do is 270 divided by 360. I'm going to multiply that by 2, and then I'm going to multiply that by 12. And we'll just write a pi next to the answer, and that would just be meters. For number 5, I've got a right triangle and a missing angle, so I want to think about sine, cosine, tangent here, so COTOA. The 14 is opposite the angle, the 8 is adjacent to the angle, so this is going to be tangent. So tangent of x, 14 over 8. And if you don't know an angle measure, to cancel out the tangent here, I'm going to take an inverse tangent of both sides. So we're doing inverse tangent, 14 over 8. So on your calculator, you hit second tangent and then 14 divided by 8. And this says to the nearest degree, so I'm getting 60.255, so I'm going to have to round that down to 60 degrees here. For number 6, we have a regular octagon, so I'm going to take 360 divided by 8, and that's going to be 45. That's going to be each of these central angle measures here. We are going to start at point B, and we're going to rotate it about point R, which is the center. So we're going to rotate around the outside of the figure here. 270 clockwise. Clockwise is going to go around to the right. And so what I would recommend here, the 270, I'm going to take 270 and I'm going to divide that by 45 real quick just to see how many segments we're going to go around here. So if you do 270 divided by 45, this is 6. So basically I need to count 6 dots around clockwise to figure out where this point would end up. So here's 45, here's 90, here's 135, here's 180, oops, sorry, 1, 2, 3, 4, 5, and so we would end up here, H at 6 is our answer. And then let's scooch up to number 7 here. What I would do, let's break this into 2 figures we know how to find the area of. Area of the rectangle, this is just going to be base times height, so I'm going to do 9 times 15, which is 135 here. Now for the triangle, we need to figure out the base and the height. If this whole thing is 20 and this much of it is 9, then this little piece right here in the triangle will be 11. And then this whole side going vertically here is 15. If this much of it's 8, then this little dotted line here is going to be 7. Now for your triangle area, don't forget it's 1/2 the base times the height. So I'm going to have half of 77 there, which is 38.5. That's going to be the area of the triangle. So what we want to do for the area of the total figure, 135 plus the 38.5, which is going to give us 173.5, and then centimeters squared since we're talking about area. For number 8, you want to find the directions based on how you're getting to the vector to get the direction. So this is the west side of the compass here, and I'm going down 15 degrees from that, so I would call that 15 degrees south of west, because you're going down from the west side of the axis.